Hey guys, welcome to 2.2 Basic Differentiation Rules, Day 2. In this lesson, we're going to be doing what we learned in the last video, except now we're going to be applying it to certain situations or certain scenarios here. So example number 1, determine the points at which the given function has a horizontal tangent. So let's analyze this. So determine the function, so determine the points at which the function has a horizontal tangent. What does that mean? Let me draw a picture. If I draw a tangent line at the maximum or minimum of a function, that is a horizontal tangent. What is the slope of a horizontal tangent? The slope is 0. Okay? So what does that mean? That means that the derivative at whatever x value this is right here, the derivative of whatever x value that is 0. So that's what we're going to be doing in the first example. The first thing is find f prime. Second thing is set f prime equal to 0. And then third is solve for the x values that make the derivative equal to 0. So let's begin. F prime of x is 3x squared minus 12x. Oh, I'm sorry, minus 12. That's my first step. Second step, set that equal to 0. 3x squared minus 12 is equal to 0. Third step, solve for x. 3x squared is equal to 12. I just move the 12 here to this side by adding both sides by 12 and then dividing both sides by 3. X squared is equal to 4, and then square rooting this, and you get x is equal to plus or minus, not 4, plus or minus 2. Don't forget the plus or minus, okay? Every time you forget a plus or minus, a baby panda dies. Don't kill baby pandas. And that is our last step. So these are my answers. That means that whatever this cubic function looks like, however it looks like, there is a maximum or a minimum at x equals plus or minus 2. That means a horizontal tangent. So let me go ahead and just draw a picture. I have no idea how this graph looks like. But all I know is that it's a cubic function. It's positive. That means that the cubic function falls to the left, but rises to the right. Okay? And this is negative 2, this is positive 2, and it probably looks something like this. This is only a sketch. There's a horizontal tangent here, and there's a horizontal tangent here. Okay? That means that at x equals plus or minus 2, the cubic function has horizontal tangents, which occur at the maximum and the minimums. Okay? So that's one thing that you guys want to maybe want to write on your notes. Horizontal slopes, or we can say horizontal tangents, occur at max minimum, or we should say occurs at the local max and local min. Local max and local min means that the graph goes up and then down, you have a maximum, or the graph goes down and up and you have a minimum. Next example. Determine the points at which the given function has horizontal tangents. Okay, so same thing. First step, find the derivative. Second step, set it equal to 0. And third step, solve x. F prime of x is equal to 1 plus 2 cosine x. Now, the thing about trig functions is that when you're solving a trig function, there are infinite amount of solutions. We're not interested in finding all solutions. We're only interested in finding solutions, and they even tell you how many solutions they want you to find. Only find the solutions that lie within 0 to 2 pi. So this is the time for you guys to go ahead and take out that unit circle. Take out the unit circle, and then you should see that on your unit circle you have 0 degrees or 0 radians, and 1 full revolution is 2 pi. And all the angles in between could be your solution. We need to find out which ones. Okay, so let's go ahead and set the derivative equal to 0. If I solve for x the same way I solve for x in any other equation, I should get 2 cosine x is equal to -1, and then cosine x is equal to -1/2. Now, here's where you're going to stop. You're going to stop and look at the unit circle. What does cosine mean? Cosine relates with x, okay? Not because there's an x here. No, that has nothing to do with what the cosine is. Cosine we know is the x and sine is the y. So I want you guys to look at the unit circle and find which angles of cosine, what angles of cosine give you a -1/2. So give you a -1/2. So if cosine is x, in which quadrants does cosine lie that is negative? Well, that should be in quadrant 2 and quadrant 3. So now find out which angles give you -1/2 in that quadrant. And it should be 2 pi over 3 and 4 pi over 3. So that means your solutions are 2 pi over 3 and 4 pi over 3. That is how you solve the trigonometric equations. Now, last example. Find k so that the function f of x is equal to x squared plus kx will be tangent to the line y is equal to 2x minus 9. So let me draw a picture. We need to find out the k right here that touches the graph with this line. Okay, so I'm going to say this is the parabola. I have no idea how the parabola looks like. I may be totally off, but all I know is that I have a line that intersects at -9 and it crosses the curve at one point right here. Okay, so what does it mean for a tangent line to cross the curve or to touch the curve at one point? It means that this equation and this equation are equal at one point. So let me go ahead and construct the equation. X squared plus kx is equal to 2x minus 9. So that is my equation. So what else do I need to know? Well, what is the slope of this line right here? The slope of that line is 2. So that means that my tangent line, whatever this tangent line is, has a slope of 2, which means that at this point, my derivative, my f prime of x, should equal 2. So let's first figure out f prime. Well, what is f prime? F prime of x squared, f prime of x means it's 2x plus k. Now, because this tangent line has a slope of 2, that means my derivative must equal 2. So that means 2x plus k is equal to 2. And let's go ahead and solve for k. K is 2 minus 2x. I simply just move the 2x to this side. Now I have two equations. Let me go ahead and highlight these two equations. This equation that I just highlighted, it's supposed to represent a solution, one solution, because if the tangent line hits the parabola at one point, then they must equal to each other at one point. So I equalize the two equations, this equation and this equation. This equation that I just highlighted here in the bottom means that when I took the derivative, because we know the derivative is 2 because the tangent line derivative, the slope is 2. So I set the derivative equal to 2 and I solve for k. And now if I want to solve for x, here's what I need to do. If I want to solve for k, I'm going to set this, since this is k, I'm going to bring it up here. So let me go ahead and shoot this to this side over there. x squared plus 2 minus 2x k is equal to 2x minus 9. Distribute that. I'm sorry, that's supposed to be x. That is supposed to be x. I replaced k with whatever I just plugged in. So that's x. Distribute x here and there, and I should get x squared plus 2x minus 2x squared is equal to 2x minus 9. Notice I have a 2x and 2x. Those go away. So I should get, on one side, I should get negative x squared equals negative 9, because the x and the negative 2x will make a negative 1x. I can multiply both sides by a negative. Now I get x squared is equal to 9, which means x is plus or minus 3. That's not my answer, however. My answer should be k. So I'm going to use this equation here, and I'm going to plug in the positive 3 first. K, 2 minus 2, positive 3, is 2 minus 6, which is a negative 4. There's one k value. Now let's look at the other k value. So here I have, let me see. Let's plug in the other x value. So it's 2 minus 2 times a negative 3. And 2 times a negative negative is a positive 6. So it's 2 plus 6, which is 8. So these two k values give me this tangent line up here, which is 2x minus 9.